I am cautiously optimistic.
Is the microphone off good?
It's no, it's working right now. Okay, so the built-in mic is working on this thing.
On the Mac?
Yeah. So hold on, it's a little behind, but so why don't you talk for a minute? Tell us something interesting, because I think this mic's going to pick you up just fine from here.
I'm trying to think, what should I talk that isn't the talk?
What's left in your face?
New house?
Yeah, it's for I mean,
1,900 square feet, so it's not a huge place.
bedrooms,
Four beds, 3 baths. Older home, but it's right on this sort of like a canyon, but it's not really a canyon, which means it's impossible to get property insurance in Southern California. If you live anywhere near something that might possibly be classified as like wildlands or grassy hill or pretty much anywhere, nobody wants to insure you because, and I assume it's the same up here. Basically, we have the California fires every October, so the insurance companies won't touch you. So I had renter's insurance at the other place we were renting in the meantime. They were upset with me because I let the policy lapse. And the reason I let the policy lapse was that they were unwilling to insure the new house. It took like a couple of days to find an insurance company that was willing to insure this house. And it's on a natural preserve. It's not very big. And there's a pond, and it's very wet ground. It's like absolutely not a fire hydrant, right? But
how big is the lot?
it's about 1/4 of an acre.
What are you gonna do with this?
What
do you want to do with this?
It's actually going to be constrained by what I'd like to do with it and what I'm going to do with it are two different issues because of the financial considerations. It's because it's on a slope. It would be interesting to put a kind of a terraced thing, but
terraced? Wow.
Little bit of a terrace with a pool and maybe a jacuzzi. But I'll probably do the jacuzzi at some point. But first thing we got to do is we got other stuff to do in the house. Have to redo all the floors. Bathrooms probably get done.
So
just bought appliances
just a major fixer
last week.
Or?
Not a major fixer-upper, but nonetheless, carpets had to go. So we're putting in.
So hardwood on your carpet?
No. I was going to do wood. I was going to look at 2 bamboo, but on the basis of the combined issues of cost and bamboo has some issues with humidity and temperature change. It's called cupping, where it changes shape, and it becomes so. There's a lot of installation challenges with it, and post-installation problems. And we just said, nah, you know what? There's actually the new laminates. Started looking at laminate flooring, and their quality in the last 5-10 years of laminate flooring has just improved so much. You can't tell the difference. And it's like half the price, and it's twice as durable. What?
Polished concrete wasn't even in the running?
Polished concrete was not in the running.
So how did you find this location?
Well, we did a bit, but it's actually really close to CSU San Marcos. It's a smaller gated community. We wanted to be in San Marcos because my mom lives there, and we really like the neighborhood there. In Southern California, we have a climate thing where the climate is, if you go too far west, you probably don't have, I don't think you have quite as bad here in LA, but down south, if you go too far west, you get into this June gloom and May gray.
Yeah.
And you just don't see the sun for a couple months.
One summer, for a couple of days, my wife and I stayed at where UCSD, what's the little beach town with the...
Yeah, La Jolla.
La Jolla, at this hotel right there. And all my wife really likes to do is just lay out by the pool. And it was gloomy every day. It was terrible.
The worst month of the year in San Diego is June.
Yeah.
but you go just a few miles inland, 2-3 miles inland, and it's sunny. But you go another few miles inland, and you're just dying from the heat, especially in July, August, September. So there's like this weird strip, and it's got to be maybe, it's certainly less than 10, maybe about 5 miles wide, that runs north-south, and it's just a couple miles inland and inland of the coast. So what's interesting is the homes in this little strip are substantially less expensive than the homes, at least in San Marcos, than the homes to the west. And as you go further south, they're still less expensive than the homes to the east. Because on the east, you get on the 15 corridor, and there's all kinds of tech and all that around there. So nobody wants to deal with the commute. So San Marcos is the perfect place from a climate and price and sort of, and just the neighborhood is nice. Where I live now, I can walk to wine tasting. I can walk. There's like 20, maybe 30 restaurants within walking distance. Movie theaters within walking distance. Bowling alley. All that right there on San Marcos Boulevard.
So what's the price range?
Oh, these homes around there are right now. Probably the median price is I would guess $550, maybe not quite $6. $550, $560. Where I bought it's a little less because I bought a little further east in an area that's not quite as well known.
You mentioned it was an older house.
It was an older house, not very old. No, not older. It's actually kind of 80s.
Okay.
So it's not really old. No.
Was there any rehab done? Roof, plumbing?
We looked at we had entered escrow at another house that was built in the 60s, and that was going to need major work. And we basically looked at it and said, well, okay, I'm going to have to put another $60K into this house. And it was not in the best neighborhood. It's like, never mind. We canceled that escrow within 10 days of sort of doing the inspections and deciding that it's just crazy.
How was the bidding process for this one?
This one was not too bad. We actually had another house prior to this that we had bid on, and there's just so many offers. It's crazy. Nothing goes for less than asking. We were in a better position because we weren't contingent. So because we were renters, it just it helped us a little bit. I don't know how you can be a contingent buyer today in the market right now. So, how far? What's the farthest besides me that anyone's traveled to get here? I'm just curious.
San Diego.
San Diego? Oh, you came up from San Diego? What part of San Diego?
You guys should carpool.
What? Yeah, we should have carpooled. You actually came further than I did. You're a hero. Yeah, but no,
you don't stop at the orange curtain.
Strongly consider it.
You guys need to have an adjunct or something down in San Diego, and I'd be there more.
Well, actually, Orange County kind of went offline, so it's just LA.
There's a lot of Unix down in San
Oh yeah, no, there totally is, but connecting the groups up, I think, is.
I could probably get Qualcomm to host it over in the queue.
Yeah. Yeah, well, it's really a body who would want to make it happen. Like, if somebody gets on the mailing list. Oh, hey, let's do a UUASC-SD, or if you want to do it. I mean, it's. I mean, what's the meetup? See, here's enough about real estate, but let's talk more about San Diego. What's the technical meetup? What's the community scene like over there?
I actually don't know, because I'm pretty much a hermit.
Okay. And you don't hear about much. Well, I'm sure there must
I
be
mean, I
meetups happening in San Diego proper.
I don't see them too often. It's like, I think everybody just waits until Lisa to go down
No.
there, right?
And Scale.
And Scale, yeah.
Dude,
But
Scales in
Scale
Pasadena
Scale's up
now,
here.
it's awesome. It's
I haven't been the last couple of years.
yeah. Last year they're hosting it in Pasadena, and it's right in the middle of town, more or less.
Yeah.
It's perfect. Oh, there's a Stone Brewery, like 5 blocks away. The little Stone Brewery thing right by the train tracks.
Oh yeah.
Yeah. Speaking of San Diego,
I live pretty close to the Stone Brewery.
right? So you'd have all the comforts of home. It's Scale 14X.
I don't know. Their stuff is a little hoppy for my taste. I had a porter there once,
Yeah.
and it was a hoppy porter. It's like, now wait a minute. Porters are not supposed to be hoppy. That said, their Russian Imperial Stout is really good. But my Russian friends didn't like it, so go figure.
And speaking of beer, apologies, there was a little communication issue, and the beer didn't make it today. So, but the good news is, you may have seen it on the way in, that there's a little kegerator that just showed up yesterday, getting ready to get staged. So next time we host here, we can all start our conversation around the kegerator.
So I should have come next month.
Yeah, no, but then you'd have a hard time driving home.
That's
So
true.
probably works out just as well.
Well, maybe I won't be so late getting home then.
Well, Firestone does have a shop on Venice now.
That's right. Hey, maybe we should check that out after the meetup. There's food, right? They have.
Yeah, if they have 1.5 seats open,
Oh, it's really crowded?
maybe.
Oh, that's another requirement. Or well, yeah. That's the one problem about this location. There's nothing walking distance, because the taco truck that's embedded into the Home Depot closes at about 8. Oh, that's a good question. The Whole Foods. There's a Whole Foods.
Yeah, I saw it over at the.
They have these 2 skillet things. So one is like pork belly and macaroni and cheese. Sorry, Lars, I don't think there's any low carb options
We
here.
have an entire like smoked meat counter.
That's true. Oh yeah. No, you can
Order a
pick and
pound of
cheese.
brisket.
But this other skillet thing is a poutine with pork belly in it. Oh, it's so awesome. And then they've got beer. That's what we should. I wonder how late they are open.
Gastro bar is probably till 11.
Yeah. Okay. Yeah. Maybe we should try that after the meetup. Good. I'm glad you made it. So we'll kick off in a few minutes. There's sandwiches over here. This is Garrett, our speaker. Ask him anything. We've covered real
I might
estate.
even answer.
We've covered San Diego real estate, San Diego meetup community, and San Diego beer.
Is the microphone on or off?
The microphone is on.
Did that change the
Here,
question?
hold on. I can mute it. Let's do a mute test. Does this mute really work? Yeah, here we go. Okay. Well, you're not speaking candidly anymore.
I will be happy to speak candidly about anything. And anyone who knows me knows that about me. No holds barred. Want to get started?
Yeah. Well, let me do.
You said
But
7:30.
well, I think nobody's wandered in. We're more or less all here. So hey, welcome everybody to the July 2016 Unix User Association of Southern California LA chapter meetup. Our speaker tonight is Garrett, who will be coming on in a couple minutes. I just wanted to do some UUASC business. First, thank you for coming. Thanks everybody for showing up. I do appreciate it. I always try to find some interesting people to speak, and it's always good for when people come down and check it out. Okay. Wait a minute. You got a call coming.
Seriously?
No. I'm joking. Oh, your wife's hot.
She is. Thank you.
No, we're Facebook buddies. I know. Okay. So first thing, Unix User Association. To be a member of UUASC, if you were so inclined, all you need to do is join the mailing list. Is there anybody here that is not on the wonderful UUASC.org mail list? Well, I mean, not because you've never heard about it before.
Yeah.
So, if you go to UUASC.org, we have a mailing list there. You're welcome to join. We actually have 3 mailing lists. We have the general mailing list, which is discussion of Unix-related topics or any other loose tangent to that, much like these meetups. We have another list called UUASC Announce. That's just for meetup announcements. So if you don't want to hear all the other chatter. And this was kind of back in the olden days before Gmail did really good filtering. We had just the announce list. You just get to announce just the announcement, say, hey, a meetup's coming up or happening today or what have you. And then the third list is called UUASC Jobs. It is a moderated list that you don't need to be a subscriber to post to, and it's just for Unix or Linux job-related announcements in Southern California area. So say, for example, you've heard about some great opportunity or a recruiter keeps calling you about this awesome opportunity. Maybe it's not something you're interested in. You can just tell them, hey, go to UUAC-jobs or go to UUAC.org and send your posting over there. Maybe somebody will be interested. So we have a few hundred of our members are lurking on that list. Also, if you're on the market and you want to post up a link to your resume and kind of make an announcement that, hey, you're looking for other opportunities, or maybe you're a consultant or what have you, that's another good place to do that. Join the list if you can. I do appreciate it. Meetups. I'm always looking for interesting speakers to speak at UUASC-LA. We try to meet the first Thursday of every month. If you're interested, you can shoot me some email. You can contact me either through the meetup site or on the main mailing list or at leaders@uuasc.org. Just shoot me a quick piece of email with, hey, the title, maybe a sentence or two, what you want to talk about, and we can start a discussion and see if that fits somewhere. Please hit me up for that. I don't have the August meetup booked yet, but I have a couple of good things in the queue. So keep an eye out either on the mailing list or at the meetup site for an announcement for the August meetup. Maybe here or somewhere else in the area. It just depends on availability. And I would like to take time out to thank Verizon Digital Media for hosting this meetup, validating the parking, which is freaking awesome, and providing us some food and drink. I think it's Mendocino Farm sandwiches are quite awesome. So thanks to Verizon Digital Media for that. Verizon Digital Media, those are the people that brought you the EdgeCast content delivery network. I have to work here at Verizon on the EdgeCast CDN. We do a lot of interesting stuff, content delivery, getting content out all over the world, all those little data objects that Garrett was just talking about on people's phones and what have you. How do we get that quickly to our customers all around the world? So if you're, we're always looking for talented engineers and what have you. So if you're interested in the potential opportunities here, come by and talk to me after the talk or shoot me email or what have you. So, but special thanks to Verizon Digital Media for hosting this. I guess there's no other, does anybody in the crowd have any other meetups or anything that they want to plug real quick? Yeah, no? Okay, well, with no further ado, let's bring up Garrett Diamore to talk about his TCP implementation on Illumos.
Thanks everybody for coming. I'm going to talk about basically my experiences or our experiences implementing a low latency SDN for high frequency trading. So what's an SDN? If you haven't heard, if you've been living under a rock, it's a software-defined network. Stop switching. There we go. So what is software? What is the distinction here? And this is really important because it drives the whole sort of justification for this project. So in our space, we have basically presence in a few of the main data centers in the world, and there are traders who want to trade between with different banks. There's a number of different banks, a number of different trading institutions, and whatnot. All of these things are traded not over the open internet, of course. They're traded typically using historically direct cross connects. So somebody would go and pull a piece of glass from one rack through the data center to another rack. And there were separate pieces of glass running between each organization's different each of the different organizations. So you understand this is a combinatorial thing, right? With a number of cables involved. But also, it turns out that to get into, for example, NY4. So NY4 is the main data center in New York where this happens. So our main data centers that we deal with at Lucera are NY4, LD4 in London, and CH2, Chicago 2. These are Equinix data centers. So to get through the bureaucracy of getting these cables pulled, you have to get various approvals, and then you have to get somebody to actually pull the cable, the budgetary constraints and all this. It takes weeks. I've heard of cases where it's taken months. This is a real problem because while these weeks are happening, trading isn't happening. Those two parties are not trading. That's a huge potential for lost economic opportunity. So Lucera has this thing called Connect, which is a product name for our SDN. And basically what we do is we have everybody pull their cables into our rack. And then we arrange through various things like there's this notion of an LOA, letter of authorization or approval, that allows us to set up connections on demand between different parties. So we're kind of an internet exchange, if you will, for trading. This works because we have connections to a lot of different potential trading partners. But it's not just an open exchange. Both parties still have to agree to go through that they want to speak to each other. So there's a mechanism for that, and we set it up through software so that we can connect these guys, and it's on a per TCP port basis. So
Wow.
Typically, we can connect two trading partners in a couple of minutes. So, or in worst case, if somebody actually has to do something more sophisticated, it might be half an hour. But it's typically very much shorter. And that's when you think about millions of dollars trading per day, think how much lost revenue or isn't lost is captured revenue or captured opportunity.
That's kind of heavy stuff. Let me drill back a second. So you guys are represented in portions of various data centers in various regions.
We have racks or cages.
Yeah.
In the various data centers.
And then you've got good data path in between each of your points of presence or whatever. That's
correct. Actually, we're partnered with Equinix.
Okay.
And we have our own effectively fiber connections between each of the various.
Kind of run on their backbone.
Yeah.
Between their
But
data centers.
they're allocated for our use in this sector.
Right.
So
But when the customers are connecting in, how do they do that?
so when the customer first creates a relationship, instead of creating a relationship with each of the different banks, they create one relationship with Lucera. And we set that up, and we do a cable pull.
Okay.
They do a cable pull, but it's one time.
Okay.
Once it's done, then that's all that needs to happen.
Right.
The next time they want to communicate with anyone else who's a Lucera customer, they can just go on the website and order it out.
Got it.
So the purpose of all this is specifically for high-frequency trading. What is high-frequency trading? And how? So there's actually people have different ideas about what this involves. There's an extremely high-frequency trading where people use custom FPGAs and they trade at extraordinarily high rates and with an extraordinarily high risk if they get it wrong. There's cases where you can go from being very flush to bankrupt in like seconds with some of the high frequency algorithmic trading. That's not our customers. Our customers are trading primarily foreign exchange using a TCP protocol. It's actually FIX is the protocol that can sit on top of several different transports, but most commonly it's TCP. There is some UDP used for, but tonight I'm going to talk primarily around TCP. The payloads are small, 200 byte payloads. Whether it's a purchase or just a price data, small data, and it's fairly asymmetric. You get a lot of market feeds and then an occasional purchase. Or you'll also see something about the shape where a price changes and suddenly you get a storm of attempts to buy or sell. So the critical thing about this traffic is that latency, it is extraordinarily latency sensitive. So in high frequency trading, it is really an arms race. It is economic warfare. It's economic warfare between banks and in some cases between countries. And technology are the weapons. Being able to execute a transaction, it's not the question of how many microseconds. It is if you're 1 microsecond behind the guy the other guy, you're 1 microsecond too slow. Because there's a certain amount of liquidity. Being able to execute on that liquidity. I'm not a trader, so I may be actually getting the terms a little bit wrong. But conceptually, the idea is there's when somebody makes an offer, if they're selling imagine somebody's selling a car. The first guy in to come in and make that button, I say, I want to sell my car. It's I've got this Rolls-Royce Silver Cloud. I'm putting it up on the market for $1,000. I only have one to sell. The first person who comes in and says, "Yep, I'll give you $1,000." That's executed. I no longer have a Rolls-Royce Silver Cloud to sell. So the second guy lost out on that opportunity, and the first guy didn't. So it's a race. The traffic is extremely bursty. By that, you'll see periods of time where there's almost no traffic, or just this kind of stream of sort of market data, but not a lot of price changes. But then when a price changes, you'll see a swarm of traffic. There was I was trying to find the research where I read this. I read this in the last month, and I couldn't find it when I was preparing my slides, which is the reason why I haven't cited it more explicitly. But there was a statement made that basically within the first 10 milliseconds of a price change, 30% of the volume of trading happens within that first 10 seconds of a price change. So 10 seconds is sort of the critical value. And a little dirty secret, we don't actually care about bandwidth. We do care about packets per second, messages per second, but it turns out that you see all this 10 gig and even 40 gig being run through data centers, and the future will be 100 gig. It's not because they need the bandwidth. It's reducing latency, and it's some level packets per second, but it's primarily around latency. So what is latency? So, sorry, my slides got reordered. Don't know how that happened. So there's different levels of latency, right? So you think Twitter, you get somebody tweets and you get it pretty quickly. You feel pretty good when you get a broadcast to the world in kind of a couple seconds, right? You can respond back. You get these Twitter responses back, and that's great. Talk about web servers and typical user responses. We see if you get a page load completes in a second, you feel pretty good. You're not going to worry about that too much as an end user. Real-time strategies, real-time strategy players, they can actually go, that number is low. They can actually go even higher because they don't have to do so many things per second. You look at console gaming runs, we're getting lower now. We're down to what, 20th of a second. In fact, I was reading 2 days ago the controller latency on the PS4 is about 100 milliseconds. Voice and video chat, you think that's got to be low latency, right? Well, 20, 40 milliseconds. And more than that, and you start to notice it's called lip flap. So 20 to 40 milliseconds, you need to keep it under 40 milliseconds for that. Trading, I just talked about that. Trade execution. 30% of all the trades and volumes happen within the first 10 milliseconds of a price change. Certainly, if you're outside of that bound, you've missed it.
So if you're on the other coast,
That's right. In fact, if you're not in the data center, you've missed it. Right? So that's why if you are trading, you have a presence in LD4 in NY4. If you don't matter. You're not a player. If you're working with on the New York, in the New York market.
By the way, is NY4 actually in New York or is it in New Jersey?
I think that might actually be in New Jersey.
Yeah. Okay.
But the data center is called NY4.
Got it.
I haven't actually been there. We do have people who go there. I don't have to go to the data center. I'm a software engineer. I'll come back to fix in a minute. So Open vSwitch. This is a software layer switch, 50 mics. That's kind of typically about the best you can get with that. Hardware switches. I seem to recall a statement from one vendor, a vendor who runs Illumos, but they use a physical switch chip from Intel or Broadcom, and they're typically in the high orders of hundreds of nanoseconds for packet forwarding. Fixed traders, they would like to see the traffic get from one point to the other in under 100 mics. 100 mics is sort of the market goal here. We'd like to, again, for our customers, the lower we go, the better a weapon we are. And we want our customers to succeed. In many cases, our customers are ourselves. Because we run, even though we're not doing the trading, our platform, we have a software trading platform that is, we basically consume our own dog food internally. So what are the kinds of options? Well, one of these things, actually, before I do that, let me go back. There was another slide here. Oh, so these are some other requirements that came out and for what we needed to do. Pure TCP, and it has to be terminated. We can't use NAT. That was a business requirement. Commodity, we wanted to be able to use commodity hardware. It has to scale. We have all these different traders coming into our data center. And basically, these guys, each one of these traders has a cable that comes and plugs into a NIC on one of our SDN nodes, if you will. We need deep analytics. Customers are always saying, and you know what, if they experience a 10 millisecond delay, you have to be able to be prepared to answer the question, why was there a 10 millisecond delay? What happened? When somebody's trade didn't execute, you get an angry trader on the phone, and you have to have the ability to answer those questions. Is it on their end? Is it on our end? You know, something happened. There's also a need for a kill switch. Remember I talked about this these algorithmic traders where you can lose a crap ton of money, like, you know, in a heartbeat or two. You need to be able to kill, and it has to be at various different levels. Some of this is regulatory driven. Some of it is just good sense. If you're, I don't know, a Deutsche Bank or somebody else like that, I'm not picking on them, I'm just picking a big name. You want to be able to kill one bad feed or one bad trader, which may be somebody's program is misbehaving and spinning out of control, and you know, somebody mixed up a sign in a program or something. So you want to be able to kill just that. You need to be able to kill it at various different levels. And of course, in today's world, you have to be resilient. So if one feed is down, you want to be able to fail over to another feed. There are challenges for doing that with TCP, but fortunately, the fixed protocol consumers will, if you kill a connection, they will typically reestablish a new one and carry on. Certainly, our so we explored, and actually we've used at various times a variety of different solutions. So I'm going to talk without naming names about which solution they are. I'm going to talk about the kinds of approaches you might go about to solve this problem. One would be to put this stuff, I apologize if the screen is cut off. Actually, can we, maybe it's as low as it go? Okay. Okay, so one of these is an open source, basically, user space application that can do this. It runs everywhere. You guys, if I mentioned it by name, there's probably at least half of you already know what I'm talking about without me naming it. But one of the problems was that it has some serious performance problems. It has performance problems stemming both from its internal architecture, which was designed around basically solving HTTP, and also, by the way, optimizing the latency around HTTP connection establishment. I'll come back to that in a minute. As well as being in user space, you have all the penalties associated with crossing the user space and kernel boundary, and with getting context switches between these things, and a gazillion different of these applications also competing for both CPU time and memory resource and so forth. Because remember, we want this to scale because we have many of these ports all coming into the box. So if you're going to have this particular kind of application, you're going to have many instances of this application all fighting for the same system resources. This particular application and pretty much all of the other ones we looked at also offered no internal insight into how it was operating. You couldn't see what was happening, and certainly there was no like, you couldn't pick out a TCP connection and say kill that one. So about the HTTP connection establishment. So a lot of people, and there's been a lot of work around HTTP for optimizing for latency. So the problem that people are trying to solve is that it takes a long time to establish a connection. This is what most of the work being done at Google around Speedy and Quick is designed to solve. And it's mostly because, frankly, these phones, they move around, connections come and go all the time, and that's what's killing them. We don't have that problem. And they're solving, their optimizations are still kind of, remember these numbers, sort of millisecond order. We're trying to solve microsecond order latency problems, but we don't have to worry about the time it takes to establish a TCP connection. Because what happens at start of day is these traders will come, they start up their app, and it establishes the connection. It's a long-lived TCP connection. It stays up for the whole trading day. So, another way to do this was with custom hardware, or even some quasi off-the-shelf hardware. So there's some options available that will do this. For example, using hardware NAT. Remember, I said NAT isn't an option, but we did actually try it. Oh wow! So we could adjust it. The good news here is, remember, The hardware could do this in sub microsecond time. That's awesome. But you're not terminating TCP. I don't know anybody who can terminate TCP and get ingress to egress of like this kind of a proxy, a sub microsecond time. Generally, these products like switches have really good visibility into them. That is a differentiator usually for them. If they don't have it, it's a negative differentiator. It's extremely expensive. So from a cost perspective, understanding that our customers have a fairly elastic price tolerance, because they're, remember, millions of dollars perhaps per day. So they're willing to pay some to have the best solution, perhaps more so than other industries. But still, it becomes very expensive because you could have a lot of these applications running, and you have a limited amount of NAT tables, so you wind up having to counteract that with more switches because you wind up having to have less density per port in terms of applications per port. It's also, typically, these things are hard to integrate into your orchestration software, which was a critical part of our value add, right? We want customers, ideally, to be able to go to a web page, click this on, connect their applications and go, right? So we looked at another option. Well, Pluribus is one, for example. I think Arista can do this. Cisco products can do it. Another option is to use something like application onload or open onload. Basically, if you drive the TCP stack up in user space and go ahead and still run your user application. Well, that helps eliminate the jitter. It does give you some performance benefits for a single screen. And yeah, we can get down to around 10 mics. Great. The problem is that one is you do have vendor lock-in, because typically the onload capable NICs only come from a small selection of vendors. SolarFlare is a good example. And there's a limit. They generally, in order to get this application onload to work well, you can't, that architecture does not scale to a large number of these proxies. It's great for running a single application or with a limited number of threads, or just maybe even just a couple. When you have the number of things that need to do this that exceeds the number of free cores you have, you're going to start running into scalability problems. And then you're going to start running into context switching and the costs in the kernel. And you still have all the issue of the number of instances of this and memory pressure, memory contention, page MMU table contention, and so forth. So, and we still have all the visibility problems we had before, because all we've done is we've just replaced the kernel mode TCP stack with the user mode. So we took looking at these, we took a different approach. If you look at what the application mode, or pardon me, user mode TCP stacks do, what they do is they eliminate the cost of getting back and forth between kernel space and user space. But what if instead you just move the application down into kernel space? That's basically what we do. We get this low, very efficient, predictable jitter. In fact, it's much more predictable even than moving the user space, the stack into user space, because we're no longer fighting the kernel schedule. And the cost to go to context switch between kernel threads is extremely lightweight. I don't have to change MMU tables. I have one address space. So I have extreme scalability. I have one multi-threaded application. I fire up a kernel thread or two per proxy. Kernel threads are super lightweight. I can have, I've had thousands and thousands of these running on a single box, no problem, no sweat. I start to run into problems actually moving the statistic data to track them more than actually running them. So we have extremely good visibility because we have a bunch of stuff, and I'll talk about this, where we wrote the application. There's nice kernel frameworks that allow us to express this. I have a kill switch. I can find and kill an individual TCP stack. And I'll actually demonstrate some of this stuff. All manageable, runs on basically any hardware. But it has a negative. It's custom software written by a kernel engineer. Kernel engineers aren't the cheapest people to keep on staff. It also has this, not using NAT. This con actually relates to the fact that it's terminating TCP. So all the ones that terminate TCP have this problem, which is that if, for example, somebody's using a delayed add, or one side doesn't see SYNs or other control traffic coming from the other because it's terminated in the proxy. So then the other side doesn't see it. They see only, they think their peer is basically this application running in kernel space, rather than the far remote peer that they're communicating with. It is a loadable kernel module. I'll actually demonstrate it here in a little bit. So this is the choice we used. Program is called, kernel module is called LT proxy for Lucera TCP proxy. Runs with the Lumos kernel modules. We wound up using SolarFlare NICs, and I'll talk about that. Basically, we found that there was some performance gains in doing so, and I wound up working pretty closely with the SolarFlare engineering team to basically bring the driver to a Lumos. And we use Dell commodity server hardware, nothing special, right? One cool thing is we can run TCP because it's just data, a data stream. I can have TCP v4 on one side and TCP v6 on the other. Or we can have two proxies and and we do in some cases, use v6 between the proxies internally and express v4 outside. This gives us some address space isolation as well. Well, I already talked about the rich kernel stats. I'll show you that. I have actually configurable policies around how we handle failure and also load balancing. I didn't mention load balancing here, but this also provides a load balancing as one of the sort of policies that is there. It's also zero copy. What this means is that when a NIC receives a packet, gives it to the stack inside the kernel, there's a piece of data, metadata called a message header, effectively, that tracks. It's not passed on the wire, but it's just internal. An MBUF in Linux, I think, is what they use. It's a message block in Lumos. So we just pass the message block. We basically pass the packet by reference, if you will, from one side of the stack to the other side of the stack. And in fact, more often than not, the data is still in the cache, and the DMA can go nice and quickly. And if it hits the same NIC, it might even be cached on the NIC. End result is lower memory overhead, certainly extremely low CPU overhead. If you did this in user space, you would be copying this message all the way back up, even if it's just DMA, out to user space. You still got to copy it out there to user space and copy it back down to the transmit side. Here, it hits kernel memory, and we're just moving the reference, basically, the handle, if you will. It's maybe a dozen bytes of data that have to move. We had some challenges with this. The first one was that I wrote this as what's called a Streams Mux driver. Anyone here familiar with Streams? Wow. Anyone use Mac OS before 10? So Mac OS 9 and earlier had Streams. Streams was a System 5 thing. It was used in networking in Solaris as the primary mechanism up until Solaris 10. In Solaris 10, there's still, and later, and Illumos, we still have streams under the hood, and there's still a lot of it used, but it's not as intrinsic to the stack as it used to be. But we still wind up passing things called M blocks around, and there's, under the hood, it's still a lot of streams. A Mux driver basically is a module, and you have all these different streams that come into it, and it figures out how to move data based on internal logic inside it to move it from one stream to another. Turns out this was really hard to debug. We had a problem where it was because we're terminating TCP. Normally you'd think you can't reorder data in a TCP stream. If it was NAT, it would be impossible for it to be reordered. This TCP guarantees strict ordering. But because of the scheduling and locking, when we crossed this MUX, it was possible for messages to very, very rarely get reordered. This caused a huge amount of heartache, almost impossible to debug. And there was actually multiple kernel modules because it turns out managing streams from a streams module is difficult. I wound up basically tossing it. The other part of the problem was when I sent this out to some other parties to review, some people who we've actually contracted just to help me review this, the reality is it's really hard to find anybody else who knows anything at all about streams. You don't know anything at all about streams until you've written a MUX driver. I don't think there's very many people left on the planet who've done that. So basically we abandoned this particular approach and rewrote it using a more traditional multi-threaded model inside the kernel. Why did I start with the MUX driver? Because with the MUX driver, what would happen is that I would get an interrupt from the NIC. I could pass the message up while it's on the context of the interrupt thread and put it in from the same thread. It would call all the way through to schedule it for transmit on the outgoing transmit node. So it was actually there was no kernel thread context switching, if you will. But it turns out that the benefit of that came at some other cost, all of these, and the benefit turned out to be really, really small. Experimentally, I discovered that basically kernel context switching is thread switching inside the kernel is so lightweight that it really made no difference. And the end result was a more synchronous model that was easier to understand. I want to talk, as we go through, I'm going to actually show you some of the problems that we encountered and show you how we solved them. And hopefully that what will happen is that you guys may be able to use some of this in solving some of your own kinds of problems that you have with performance around networking. So the first problem we had was, I call it NAGLE the first because it was the first time it showed up. Everybody here know what NAGLE is? TCP no delay? I see some heads going, huh? So basically the concept is that if you're going to get some data to send, you might be getting some other data pretty soon. In the old days of Telnet, when you were transmitting keystrokes, your TCP connections were primarily interactive data. Sending 1 byte, to transmit that 1 byte of data, you'd have at minimum 40 bytes of header. So it was pretty expensive to do that. Well, if somebody's typing, in a few dozen, in a few dozen milliseconds, there should be another one coming too, right? So why don't I wait a few dozen milliseconds and see if I can gather some of these up? So that's what NAGLE is all about. It's about holding back on the transmit until I actually have enough data to buffer to either fill a TCP segment, or after enough time has expired, I give up and I say, yeah, okay, it's time to send this off before the expiration date on it passes, right? Well, the expiration date is really, really long. Remember, the 500 milliseconds, not a big deal for humans if you're typing. Absolutely devastating for a high-frequency trading application. Just forget it. I mean, so we optimized. So this stuff was optimized. This algorithm was designed. I think 110 baud modems. Anybody else here ever use a 110 baud modem? Oh. So what's shocking is that this is on by default. When you just open naively a TCP connection, almost everywhere, this algorithm is turned on by default. Absolutely insane in today's world. But yet there it is. It's almost wrong. It's almost 100% wrong. I think the few times where it makes sense, maybe for interactive SSH connections. I don't know anyone. I don't know anyone who uses interactive telnet except perhaps when they're debugging SMTP or something, right? And in those cases, you don't really care about the odd 500 millisecond delay, or the odd 500 millisecond delay, or the 40 bytes of overhead. On today's networks, 40 bytes of overhead, who cares? Another issue we had was NIC jitter. Whoops. So NIC jitter was caused by the default tuning on a lot of NICs. They're either completely untuned, or they're tuned badly for this kind of application. So if you think about what NIC vendors typically tell you, they typically are trying to push fat pipes. How much bandwidth can I get from point A to point B? 10 gig, 40 gig. I can get line rate. No, that's what they like to say. I can get line rate. Guess what? We don't care about line rate. The problem is that all the tricks you do for line rate, the best way you can get to increase your data rate is, frankly, to make sure that your pipe is always full. You're always transmitting data. So hold your data a little bit, let it queue up, minimize the window of time that the wires are idle between packets. That comes at a cost. You're creating a delay. And the cost is that it's a latency. So the defaults on these things are pretty terrible. But then we also see some really horrible implementation. So IXGBE, probably lots of us use that in production. Some of the phi reset logic code in that is just horrible. It's gotten better, but I was seeing like 10 milliseconds of just spinning on the CPU, waiting for the phi to reset. And while it's spinning, that core isn't doing anything else, including anything that would normally be scheduled on that, like, say an RX interrupt. We also saw this. This was actually not a driver bug, but it was a bug caused by incorrect tuning by folks who did not understand the architecture of how these NICs are designed. So with modern 10 gigabit NICs and even 1 gigabit NICs now, you start to see this stuff around. It's marketed as RSS, receive side scaling. So the concept is that in order to get the performance, in order to get that line rate that we were just talking about, you want to spread the load out across as many cores as you can to get everything running in parallel. So they have a bunch of rings. But then somebody says, some guy says, this is silly. We're worried about latency. And having all this spreading out is crazy. So let's actually take all those rings and just schedule them all in one core to keep everything hot and in cache. That was the advice that was given, foolishly. So what happened though is we had, I think the default was 8 rings per NIC. I think that's the default for the IXGB NIC, all hitting the same core. And then we had, I think, 16 of these NICs in the chassis. So you have 8 times 16. What is that? 128. 128 rings, all on the same core. Now, little known fact, if you're not a kernel engineer, is that interrupt scheduling is not fair. And it can be, but typically it's not. What happens when the interrupt fires? The OS looks and says, okay, who's first in my list of things to execute? Execute that. Did he do some work? Okay, finish the work. He runs. Did he do some work? Okay, good. I exit him. I return from the interrupt handler. Oh, the interrupt bit's still stuck. Go back and try again, starting again at the head of the list for that first guy. And I only get to the second guy when all the first guy's work is done. Now we've got these rings 128 deep. If your packet happens to be unfortunate enough to arrive on that 128th ring, you're not getting service until everything else before you is empty. So what would happen is during peak periods of traffic, we would see these really weird latency spikes, just these huge outliers, hundreds and hundreds of milliseconds. And the guys looking at the packet traces just couldn't understand what was going on. And it wasn't until I was asked to look at it, and I realized, well, wait a minute here. You've got all these interrupts and rings all hitting the same core, you're starving this last one. So the moral of the story here is you really need to understand the architecture or have someone who understands the architecture to help you tune. Naively, just applying a rule, which is what was done here, can hurt. And this one hurt badly. This was a challenge we saw with the solar flare NICs during early development. I noticed that KStat would run, and it would sometimes take 8 seconds to complete the KStat collection. And what was happening was that the firmware had a long-running thing to collect the data, and it was not very long. The solar flare engineers didn't think it was very long, because on an individual NIC, it's not too bad. But they didn't understand at the time that people run this data, they run a KStat collection like once a second. You put this in an SNMP thing or whatever, you're collecting this data really frequently. Once a second, that seems reasonable, right? Or even once every 10 seconds. But now this thing was, with 16 NICs, it was just taking a really, really long time. And because it was a lot of NICs. And the data that was related, that was being collected, was actually the thermals on the NIC. And the Illumos driver, which I integrated, I turned that off by default. That data collection can be turned on if they need to collect it for service, but generally the recommendation is you don't need that data. No other NIC uses it. It would only be basically to eliminate thermals as a cause of problem on that NIC. But the moral here is, and I've seen this with other NICs, it was actually a number of Wi-Fi cards do this, where the KStat collection can be expensive if the driver's not well designed. And I would imagine that to be true, not just on Illumos, but on other kinds of collecting SNMP stats basically can be expensive, particularly anything that has to go out and touch hardware. Going and executing a command on the chip to collect that data is not cheap. So if you want to tune for low latency, and remember, latency here, this is sort of my guidelines. I know I just said don't be cautious about blind advice, but I'm going to give you the advice that I would give to somebody who wanted to tune for latency. And this is not a tuning for throughput, and it's not a tuning around HTTP connection latency. But it is about once you have a connection established, or if you're using UDP, put each NIC on a single core. And you know what? If you're not using virtualization, you don't need all these rings. If you don't care about, if throughput is not what's king to you, actually all that spreading can be painful. It's better to have everything hit the same. Just one ring is enough. In our case, one ring was, we were doing millions of, not millions, in aggregate about 1 million packets per second, and I could hit this no problem with this configuration. This is really critical. A lot of these NICs, in order to, again, reduce the pressure on the system, increasing your total packet rate per second or your total throughput rate per second, try to amortize the cost of servicing the interrupt by servicing it only once every however many packets. This is called interrupt throttling or interrupt coalescing, typically. This is lethal in a trading type application. If your latency problems are millisecond order, by all means, feel free to leave it turned on. But if you're worried about microsecond order latency, you got to have this turned off. Now, interestingly enough, I've said nothing about transmit interrupts, and the reason is transmit interrupts, actually you want to go ahead and leave that turned on, because you don't actually need to run, you should not need to run your transmit interrupt handler ever. On a transmit side, what happens is the NIC, you put a packet out on the NIC, right? Well, before you put a packet out, you have to collect, it's called a descriptor slot typically, or something like this, a resource on the NIC. And you schedule that for outbound. In the process of finding one to send, you can look for the free ones. The reason you need an interrupt is that if your NIC, if you can put more traffic on the NIC, schedule more of it out on the NIC, and the NIC can get out, you can fill it. And you need to have an interrupt to let you know when some data is free. But unless you're pressing against that, you should never need, and typically under steady state, you need very few, if any, transmit interrupts. So go ahead and turn those off, because those interrupts are actually painful. Those are context switches you could just avoid. Offloads. Also, any complexity that you have, with the exception of checksumming in hardware, is usually so lightweight and so fast for the hardware to do, and then not having to touch those bytes and dirty your cache. That's a benefit. And also then the logic in the driver in the drivers and the stack to take the use of that is so tiny and so cheap that you should always go ahead and leave your checksum turned on. But all your other offloads, segmentation offloads, turn those off. They will definitely have a negative impact on your latency. And typically, if you've got small frames, you don't need them. There's some other tunables that I didn't touch on, but anyway. In an ideal world, you'd like to have your interrupts handling, particularly for your RX interrupts, and the application that's going to receive those, all on the same core or package, CPU, individual package, as where the PCI interrupt for the NIC is, and also with I want to say, I'm trying to remember now the Intel name for this, but there's having the memory close there is also important, somewhat important.
NUMA?
Yeah, it's a NUMA consideration. Yeah. Well, there you go. Worst case is about a mic. If you're in the wrong place, if you got to cross that boundary, yeah. If you're on the wrong core, wrong package, and you got to go across a NUMA-like boundary, in experimentation, I found that to penalize ingress to egress times by about a mic. That's about a 10% penalty, so it's not nothing. But in our case, a mic was underneath the threshold of what we cared about. And the other part of this was that in our case, with the number of connections and ingress and egress and things moving all around the case, it became impossible to try to pre-calculate effectively the scheduling there. So we just let the operating system deal with it. When you're choosing NICs for latency, in NY4 everything is fiber. Why? Because of latency. Speed of light, copper is 1/10 the speed of light typically. It's not a lot, but again, this is a competitive market, and second is not the winner. If you're not the winner, you're the loser. 10G base T also, the PHYs on 10G base T versus CX4 are typically a little bit higher latency, but also higher power draw typically. At least that was historically. That information may be different in the last few years. I haven't done a comparison of it, mostly because we don't use 10G base T anywhere. Of course, having higher bandwidth, that's a lower propagation delay typically. So 10G is definitely, even though we're not using the bandwidth, even if you're only running 1G or 100 megabits, which is what happens in these banks, they still cable everything up for 10G. Even because again, for them, they're fairly price elastic tolerance, but the latency is king. So with lower latency. The solar flare NICs are optimized for latency more so than most of the commodity NICs from Intel. Intel is pretty, I'd say, bandwidth driven, and to a lesser extent, CPU and power efficiency driven. We don't care about power efficiency in this application. We care about latency. Latency over everything. And actually, I spent some time with the solar flare NICs on Linux, and the same results apply. They're typically lower latency by at least a mic in this application than the equivalent NICs from Intel. I did not test anybody else's NICs. The Chelsea NICs had problems, bugs involving the VLAN handling, which I think are fixed now, but at the time they were so bad that we basically didn't use them. We had to eliminate them, and I haven't played with anybody else's. In a driver code size and complexity counts, every branch, it creates an opportunity for additional delay, additional, well, this is what branch prediction is all about optimizing your instruction cache and avoiding pipeline stalls. Pipeline stalls add up, and they add up really quickly. Not only do they add up quickly, but they add up exponentially. So a little bit of delay in the wrong place while you're holding a lock prevents some other stuff, and then that's holding another lock, and it just piles up. And you can actually have fairly dramatic changes, but with just small changes to code. Let's see. This is another challenge we had. This is so I talked about Nagel before. This is in the rewrite. We saw these weird, I don't know if you can see these peaks over here. They were, this one shows them worse. The first one we saw was about 40 milliseconds. These are like 100 milliseconds. And they come, there's a periodic time as well. The period is about 30 seconds. And we spent a bunch of time trying to analyze this, because at the time, I didn't think it could be Nagel, because I turned Nagel off. In fact, I didn't even think that it could be Nagel. Nagel never entered my brain.
How does Nagel enter into this? Is this an end application issue? Are you providing the end application?
Well, remember, we're terminating TCP. So
why would you code any Nagel?
Again, I'm using the kernel's TCP stack. Even though I'm accessing it from inside the kernel.
I didn't get the overview.
Okay.
Right. Yes.
So I thought I had turned it off. But I wound up doing a bunch of packet analysis, and I actually was looking at congestion control algorithms. I thought this was congestion control getting involved, and delayed act, because it was weird. A 30-second interval was confusing the heck out of me. So it turns out with FIX, the protocol, it was very, I have to talk about delayed ACK here for a minute. So in a delayed ACK, what it allows TCP to do is not respond to say, hey, I got that packet. I can wait up to one more packet of time before I send out the delayed ACK. So when I get the second packet, or when the time expires, I have to acknowledge that I got a packet. Again, yeah, it's ACK every other way. This is again something designed around human interactive sessions, and it was an alternate approach to Nagel. It's also turned on by default on some platforms, not everyone. And when it combined with Nagel, it creates this horrible, horrible opportunity for these huge delays. The problem was, later when I was looking at the traffic, I went back into the code, and I used a technology called dtrace to look at some variables that were set during flight. And I was surprised to find that while I thought I had turned off Nagel, because of the way the session was set up, I had turned it off, or I had sent the command to turn it off too early, and then when the session was established, it got reset back to on. And that, whoops, came back and boot me. So this is a log from a good LT proxy. You have this weird banding that occurs. Anybody any guesses for what those bands are? By the way, before we do that, go back to the other one. So this graph, look at the y-axis. Pretend this is the log graph, right? Mike's on the y, time on the x, right? Maybe it's just a loop band. Now let's look at the good one. Now look at the y-axis. Yeah, I've got a couple of outliers. Hey, there's one up here on 35 points. Oh, nuts. You know what? Who can guess? Anybody have any guesses why these bands occur?
Is it a machine you buy to? Is it a bit more like see?
No, it took me a while to figure this out. So it's the clock resolution. Each one of those is 1 mic. So the ability to measure these on the appliance that was capturing it, collecting the data, was limited to a mic of resolution. I spent a bunch of time looking at this. What the heck could this be? Is there some weird scheduling thing going on that I don't understand? No. It's just the clock resolution is 1 mic. So you can see we have a nice, it turns out, and this graph has probably a few 100,000 packets in it. Samples, there's a few up there. There's probably, I have this couple 100,000, there's probably less than 100, up over 15 mics. So it's out to, I don't know how many nines that were under 15 in it. And most of them are right on the 10, 11, it's more on the 12, and then it gets out there. So one of the challenges we had with this was actually being able to simulate the trading protocols. So because of the asymmetric nature, and this is, remember I talked about the reordering problem, the data reordering, I created a tool to do this called seek test. And originally it was just about making sure that the data arrived on the remote side in the same order that it was sent on. To have a lot more capability. And this code is open source. That's the URL on GitHub. And you can use it to do load testing and pattern testing. When I say pattern testing, I'm talking about adding different kinds of randomization and also asymmetric type loads. So I want to send however many thousands or millions of packets at this rate with these kinds of delays between them, perhaps randomized, the size is randomized, and I want to have the replier send back a reply every 100th packet, and then tell me what the average latency is, right? As an example. This all works on pretty much all the Unix-like operating system. I would be stunned if it worked on Linux, on Windows, but everywhere else it pretty much just works. Getting accurate timing data turned out to be difficult because with seek test you're running on it, measuring it inside the application. You're now, when we're talking about microsecond timing, how do you know whether you're seeing times from the application? You really want to capture them ingress to egress. So you do need an actual appliance on the outside. We have a packet capture appliance that lets us monitor the wires and see the times on the wire on the Ethernet. Obviously, we have a clock resolution, microsecond clock times. Right now, that's not a huge problem for us, but it's I can see that becoming one in the future. In our case, the appliance we use is API driven. It allows us to collect data remotely and then internally process it and correlate ingress and egress data, because remember these are separate TCP streams. So we actually look at the payloads to do the correlation. And that allowed us to tell people exactly what the latency is they're getting from point A to point B, which is how those other graphs are generated. Where would we go in the future? Adding UDP support. Porting this to another operating system would be interesting. It would be a fair amount of work because this is kernel software, but it's no longer a Streams MUX driver. So architecturally, it would actually fit quite nicely into a Linux or a BSD operating system. Probably even in a Windows operating system, although I'm not a Windows kernel guy. Adding support for multi-tenancy would be nice, so that you could run this and have it accessible from different zones. That's not critical for us yet, but it could be in the future. In order to do that, we would actually need to enhance the solar flare driver to express the rings, so these receive rings that I talked about, to the operating system. It has the rings for RSS, but you need to express how to, for virtualization, you want to provide configurability of those NICs and then be able to associate them with either a VLAN or a MAC address so that you can separate that resource. And that becomes whole other topic for discussion. And I plan to actually enhance the SolarFlare driver to do that in the future. It turns out that as part of this, I also uncovered a bunch of kind of crazy code paths in the Illumio stack. There's stuff in there that is just crufty. There is some code in there that's used by one legacy NIC driver from Spark, the Cassini driver. That code needs to be gutted. Before that can be done, the Cassini driver, which is not open source, needs to be rewritten, and that's a project I have begun. And then once that's done, then I'll be able to rip out the legacy code. And that code is actually scattered throughout the stack. There's a bunch of those branches and places where we wind up making checks and carrying metadata on friends that we just shouldn't have to do. We'd like to have this more tightly integrated with our API than it is now in terms of control. I'll demonstrate it via command line here in a little bit. One of the problems with LT proxy is that it sees only, it's a TCP consumer as an application. So it doesn't, its view of TCP is just the data messages. It does not see the metadata as far as, oh, this had a retransmit, or this had this, that, or the other. At the moment, we've solved this with the packet capture appliance on the outside, so we can see that data there. But it would be really cool if LT proxy could poke into it and ask TCP, hey, how many retransmits did you have on this stream? That means adding some control messaging, basically, into TCP, perhaps via ioctl or socket option. Yeah, so tell me a little bit more about what's happening, not just the data. I want some extra information beyond it. And I've been looking at how complicated that would be to do. It's not too bad. I didn't mention demo. Let's see, how are we doing on time? It's 8:20. We have plenty of time for a little
yeah,
demo.
sure, definitely. Go for it.
Before I do that, questions?
I think in the application layer, the service that you have, you go ahead and set the maximum number of people live packets or people requests that come to.
So keep alive is an orthogonal problem to this. Some people use keep alive to prevent with mobile devices from dropping and having to pay this TCP reconnection cost. But what it's actually designed to do is two things. One is to keep NAT appliances from flushing the data, timing out of data on an idle connection and losing the connection because there was no traffic. So you get this sort of not application layer data packets moving for it to keep the entry warm in your NAT device or your firewall or whatever. The other reason is it gives you an ability, if you have no other communication happening, to notice that the other side went away. If both sides are blocked in receive and nobody's sending data, neither one will know when that application goes away, right? When I say goes away without doing a clean close. So the keep alive allows you to detect at some point that, hey, that other system crashed or the application, usually it would be the whole system, because when the application crashes, the kernel will typically send the SYN to close the whole thing down.
So there's lots of white box networking vendors now that are basically, a network backplane and a CPU very tightly integrated. None of the legacy IBM PC stuff. Like, what keeps this kind of thing that you're threading from landing on that hardware instead of on x86 hardware?
Actually, most of the white box switches right now are actually x86 hardware. Not all of them, but most of them. And one of the reasons for that is one of the biggest white box switch chip vendors is Intel. So the Fulcrum series of chips, typically. And I have some experience. What's different about that box? The switch chip and
Just too much abstraction between.
well, I'm going to come to this in a minute. The switch chip and the various BIOS bits necessary to initialize for Windows, for example, or some other system. In fact, bringing the Lumos up on some of those boxes is a challenge. I've done that while I was at Pluribus. Now, having said that, if you want to run this kind of an application, typically the way these switch chips work, they can't terminate TCP. They have some capability to do some kinds of filtering and that, but the main thing that they're designed to do is set up for packet forwarding. So that's a packet level forward. And they can do that really, really fast. Their connection back to the system. So you might get a switch chip that has, let's say, 80 gigabits or 160 gigabits of network-facing bandwidth stuck on a PCIe by 16 slot. You don't have enough bandwidth. You cannot pull all of that traffic across the PCI bandwidth. So typically, you can't, for example, do full packet capture as an example with such a system. In this kind of an application, could it be done? Could we use it? Yes, because again, our bandwidth requirements are low. And certainly, those switch chips can be configured to move data from the port through the bus and basically express it as a NIC to the host. Having said that, having experience with some of these switch parts, usually the PCIe logic on those switch chips is mostly an afterthought, used for control and management, not for actually pushing data. And it tends to be one of the dodgier aspects of these white box switches.
I still need a little overview. So you have two customers, A and B. And on your box, you're using, within the kernel, you're using the Lumos TCP stack.
Correct.
So you have two TCP connections, one going out towards A and one going out towards customer B. You're playing TCP switch board.
Yes, that's right.
So part of the establishment and the setup of this whole thing, when they check into your website or whatever you have, is to assign that port switching mechanism. They come in at a port of yours, you go, oh, 18 in here, I'm sending it out to B.
That's right. LT proxy will establish the outbound connection
So there's no
based on
netting,
configuration.
There's no netting or anything
There's
going
no net.
on. You're just using the
Straight TCP, nothing,
Gotcha.
nothing magic. And the beauty, say that again?
Is BGP involved or not at all?
No.
Okay.
I mean, that would be orthogonal, right? This is just a very, very, so the one user space application to do this is HA proxy. HA proxy is geared mostly around proxying HTTP, but it can also proxy TCP. But it has all the same problems that I discussed on that other slide, where TCP, it receives, it basically listens on one port, receives a connection, connects to an outbound port, and forwards data across them. Okay, so
kernel, you just have a reference.
yeah, exactly. It's much, much, much better in the kernel. No better. Let's see if we can make this better. Okay. All right. Oh. Okay, we're good. So this is my this is running an Omnios system in a VM on this box. I'm actually not connected to an outbound network. Actually, I think I'm on the guest network, which might be scary, but I'm not actually relying on it for anything other than to control my thing. So this has to run as root. There are no proxies configured. This creates a proxy which is unconfigured. forward properly this one. Oh, that's horrible on this little screen. I can do this a different way to make it more elegant. But let me, right now the critical thing is that this is not configured or started. So this is just a placeholder proxy. Let me go ahead and, for the sake of argument, I have to create a listen address, which is, we call it site A and site B in our parlance, so that's why this CLI is designed. And a colon, I don't care. I could put a 127 address here, but I'll just leave it out so it'll listen to everything. And we're going to listen to 488.22. So I can have up to 4 different outbound places that I could connect to. This can be used for load balancing, and it can also be used for failure. So when one is noticed to be failing, it'll move to the next one. But I'm only going to create one right now. I actually do have to give this one a full quad address because it's connected. It's a destination. I can't connect the port to IP0. And then I have to give it the proxy ID, which is this thing. These things are generated basically randomly. Oh, I'm an idiot. That's what I'm doing wrong. And I'm still an idiot. pfexec is Illumos's equivalent of sudo. In fact, I could have done. I can't do that. I didn't edit the sudo file. Guess which command I used. So that created the proxy and configured it. I'm going to go ahead and start it. I'm actually going to just say all because I'm too lazy to cut and paste. And you'll notice here it says it's running. So that means that if I just do, I'll actually create a new window. Actually, that was probably not the way to do that. It was 88.22, right? Okay. So this is now running. What's happening now is my traffic, I'm connected on port 88.22. The proxy in the kernel is just forwarding that over to port 22. So let's show you some stats. And this is kind of cool. So first off, I have, this is sort of the basic stat for the, oh wait, that's the conversation stat. So this is the stat for the whole proxy. So I could have hundreds of connections all being serviced over this one proxy. And I collect the full stats for it. So there's a bunch of stuff here around how many bytes and how many different failures of various different kinds of things have happened, how many bytes are going over that Z's, over all Z's, and then also from Z to A on the Z0, the path 0, and so forth. But I also have, and this is really cool here. Yeah, this one is actually, yeah, there we go. So I have one conversation that I've started, and only one at the moment. I've done very little traffic because it's just this interactive session. But look at this. You'll notice that's an IPv6 address because by default the kernel selected an IPv6. So I have IPv6 on one side and IPv4 on the other because they just said listen to everything and I just connected to it by. And I can see the remote. Here I can see on this connection using the kernel stats. I can see whom I connected from, including the remote port. So I could now go back on this Mac and look and see what's connected or what's using that port to find the application if I wanted to. So I have a way to go back to everything, which is much cooler than you would get with most kinds of, certainly you don't have this kind of capability with LT proxy, or pardon, with HA proxy, or with a NAT appliance. Now, let's go back here. So I have one conversation. I forgot my command, actually. It's been a while since I've done this. All right. You know what? I'll just show you one other thing, and then this will be kind of the end of the demo, unless somebody else wants to see something else. I can kill that conversation. So I'm going to show you what this looks like. So here, I'm still connected over that proxy, right? No, I'm not. So I killed just that one. And if I was actually, I can do this way. So I have two proxies up now. And the third one should be the one down on the bottom, so I'll kill that one. And this one will stay up. And this one stayed up. So that was the kill switch. So hopefully all this, in terms of future directions, I hope to be able to actually make this, put this out as open source. It's not today. And we use this internally inside Lucera. Not all of our traffic goes through it, but some of it does. At various peak times, this stuff is, you know, I think a lot of transactions have flown over LT blocks. I shudder to think that when I first started doing this, and Jake, who was the one who originally suggested, when I suggested this approach, he said, yeah, go for it. After it had been in for like a week, he says, do you have any idea how many millions of dollars this thing has done? You know, have been exchanged over this. So in closing, that's it. The main thing I hope that you guys got was not about the proxy, but about the problems and challenges associated with network debugging and latency problem. Hopefully you got a better idea of what some of the latency issues are and TCP tuning. I'm also available on a consultancy basis. If that's something that, if you've got some of these kinds of problems, I'd be happy to help you out.
From now till when you start course, how long?
Version 1 took me a couple weeks. Version 2, where it was pretty much a rewrite, and it was also kind of a week and a half, 2 weeks.
So it seems like you ran into a lot of issues.
We did, and there was a big stall in the middle. And you know, so in terms of when I say a week and a half or 2 weeks, that was time to implement. That was not necessarily, did not include some of the debugging time. So and a lot of that was driven also by being able to generate production load. So my inability at first to simulate load that matched production, which is ultimately how seek test was created, meant that there was a huge long time from the time I was code complete until we found the problem and then had to fix it. So, and likewise, the second problem, actually the second problem probably added another week, maybe 2, while we were still trying to figure out what it was that was happening. But again, I was also constrained by the particular pattern, and I didn't understand until I actually had actual production data on it. We basically ran a production market data through this for our own internal use to see how it would behave, because I wasn't seeing the same thing. And the answer was, I was actually generating too much traffic. I actually needed this kind of very occasional heartbeat to cause the delayed act to trigger the nagel and to be able to see it. When I was doing too much data, I lost that data point. And under testing, I was putting at load. I've put about 1 million packets of messages a second on this, and it has hummed on basically commodity cargo. So no sweat there.
Well, so one, I guess, kind of a Lumo-C type question, just drilling into the right? The PF exec, just to get into a sysadmin thing. Sysadmins are going nuts. It differs from a Lumos, right? It's this kind of shell that is kind of roll is right. It's a role based.
It's a role based. So actually, what happens is it lets me execute a command line under a profile. So it's RBAC.
And did you have? And you can tweak a lot of things. What the app in the shell can or cannot do.
That's right.
For LT proxy, did you create a custom role for that, or would you?
I did not. In our application, it's just easier just to run it as root. And in fact, fixing one of the things here that, if anybody was really paying attention on a security standpoint, you noticed I can run these kstat commands, and I run that as an ordinary user, and I can suddenly see all the ports that are connected, who's connected to what ports and what. That's kind of not very cool from a security standpoint. That's actually, for our case, it's a feature because we don't have user shells on the appliances that run this. I say appliances. The appliance, again, is just a commodity system with a ton of NICs and running this software. But in a case where I had actually user shells, I would want to restrict access to these statistics. And adding that capability is actually it's a low priority item on the to-do list. It's actually a pretty simple thing to do. But yeah, certainly you could, to answer your question about could you reduce this, LT proxy specifically needs the network administration rates. So, and it looks for those, it doesn't look for root. Having said that, you do need to have root to load the kernel module.
Any other questions? Okay, hey Garrett, thank you very much.
Thanks.
So thanks everybody for coming. If you want, maybe we could head over to the, there's a Whole Foods a few blocks from here, just down Jefferson. Maybe meet up for a drink and further discussion if you're interested. I'm gonna have to clean up real quick. Thanks everybody for coming out. If you can clean up any of the little stuff around you on the way out, I'd appreciate it. Keep an eye on the meetup site for the next meeting. And once again, thanks to Verizon Digital Media Services for providing the space, parking, and the sandwiches. Oh, and if you want a sandwich, those sandwiches are awesome. Take them with you on the way out if you want. Otherwise, we have a network operations center here that's 24 hours, and I'll hook those folks up. And if you didn't get a parking voucher, let me know.
360 and then 500.
Hey. Oh, hell, let me kill the live stream.
Yeah.
Yeah, everything was pulled out.
Yeah.